Welcome back to Lumicore Labs. Day 15. Let me ask you something. Has your code ever crashed because the user typed hello when you asked for a number? Or because a file you wanted to open didn't exist? Today, we learn how to handle these situations gracefully with error handling. We'll use try and accept to write programs that don't crash. They handle problems and keep running. Let's make your code bulletproof. Think of error handling like a safety net under a trapeze artist. The artist might slip, that's the error. But instead of crashing to the ground, they fall into the net and can climb back up. That's exactly what try/accept does for your code. Watch this. A simple program asking for age. The user enters their age, and we print what they'll be next year. Looks fine. But what happens if the user doesn't type a number? Boom. The program crashes with a value error. That scary red text appears, and the program stops dead. The user is confused. They might think they broke something. As a developer, you can't control what users type, but you can control how your program responds. This is called an unhandled exception, an error that we didn't prepare for. The program had no safety net, so it fell and crashed. Now let's build that safety net. Now let's fix this. We wrap the risky code in a try block. This tells Python, try to run this code, but be ready for problems. Then we add an accept block. This catches specific types of errors. Here, we're catching value error, the exact error that happens when someone enters text instead of a number. Watch what happens now. I'll type 20 again. Instead of crashing, the program prints our friendly error message and continues running. The last line, thank you for using our program, still prints. The program didn't die. And if the user does enter a valid number, like 25, the try block runs normally. The accept block is skipped entirely. Best of both worlds. This is the core of error handling. Anticipate what might go wrong, catch it, and respond gracefully. Your users will never see those scary red error messages again. Sometimes different things can go wrong. Here, the user might enter text instead of a number. That's a value error. Or they might enter a 0 as the second number. That causes a zero division error when we try to divide. We can have multiple accept blocks, each catching a different error type. I'll enter 10 and 0. The try block starts, converts both to integers, but then hits number 1/number 2, division by 0. Python jumps immediately to accept 0 division error and prints our message. Now I'll enter 10 and ABC. The int conversion fails on ABC with a value error. Python jumps to the first except block that matches except value error. There's one more powerful keyword, finally. Code inside a finally block runs no matter what. Whether the try block succeeds, whether an exception happens, the finally block always executes. This is perfect for cleanup tasks. Imagine you open a file to read it. If an error happens while reading, you still want to close the file. Otherwise, it stays locked and other programs can't use it. The finally block ensures that cleanup code always runs, even if something crashes. I'll run this. The file doesn't exist, so file not found error fires. But look, the finally block still runs. It prints closing file, even though the try block failed. That's the power of finally. In real applications, you'd use finally to close database connections, release network resources, or clean up temporary files. Anything that must happen regardless of success or failure. Let's build a simple, practical mini project. A number adder that never crashes. The user enters 2 numbers, and we add them. Then they can do it again, as many times as they want. When they're done, they type anything that's not a number, like the letter Q, and the program says goodbye and exits. All the risky code is inside the try block. Converting input to numbers, that might fail. Printing the result only happens if both numbers were valid. If the user enters something that can't be converted to a number, like the letter Q, Python raises a value error. Instead of crashing, the except block runs. We print goodbye and use break to exit the while loop. Let me show you. First I'll add 5 and 3, works perfectly. Then 10.5 and 2.5, works with decimals too. Now I'll type Q to quit. Instead of crashing, the program catches the error and exits gracefully. Clean, simple, and unbreakable. Day 15 is complete. Error handling is what separates fragile scripts from production-ready applications. You can now write code that handles chaos gracefully. In the next video, it's practice day. You'll build programs that use error handling to stay alive no matter what users throw at them. Hit the like button and subscribe to Lumicore Labs, and tell me, what's the most annoying error you've encountered so far? See you on day 16.